You can test things, break them, fix them again.
Our display is here to help you get started, to spark ideas, and to show how prints can come to life. Mistakes are part of the process, but with our provided info for the 3D printers, you can soon become a pro too. Happy printing!
After downloading Prusa Slicer, this is the first thing you're going to see. This is the setup to ensure that you get the best printing process for printing in the Swetman makerspace. So first, you're just going to want to click Next. You can choose to make an account. That's up to you. I didn't. You can, after you're done, click Next. You're going to want to have all of these selected and then click Next. Once you get to this screen, you're going to want to scroll down, all the way down, until you get to Original Prusa i3, MK3S, and MK3S Plus, and select the 0.4 millimeter nozzle, and then click Next. You don't want either of these selected, click Next. You want none of these selected, and then click Next. Don't select that, and then click Next. You can choose to make a profile name for your settings. I didn't, but you can make some things easier, and then click Next. Once you get to this screen, you're going to want all, and then you're going to select Prusament ASA, Prusament PETG, and Prusament PLA. Then you're going to scroll down to the G's and select Generic PETG and Generic PLA. These are the only ones on this list you're going to want selected, the ones I described to you, and then click Next. So you can choose to have automatic updates installed and automatically check for application updates. That's up to you. Click Next after that, and then choose where your downloads from Prusa Slicer are going to go. Then click Next. You do not want to have that selected, and then click Next. You can associate certain files to Prusa Slicer. I have neither associated, but for ease of use, you can do STLs or 3MFs. That's up to you. And then we suggest starting in expert mode. That's going to give you access to the most settings available, and then you're not going to want to use inches. And then click Finish, and your screen should look something like this, and you're ready to start printing. After importing your file to the planer, you're going to want to customize it to your liking. The first and most important setting we're going to cover is these layer heights covered here. So if you look, these numbers here, they correlate to the thickness of each layer that is going to be laid down by the 3D printer. For example, this 0.3 millimeter draft is a very thick layer height compared to this 0.05 millimeter layer height. So layer height is going to dictate the smoothness of the edges of your print. For example, a sphere printed with 0.5 millimeter ultra detail is going to be a lot smoother on its outside than it is on draft. On draft, you're going to be able to see the steps the printer takes much more clearly. Additionally, a 0.3 draft layer height can't produce any details smaller than 0.3 millimeters. So we suggest you play around with these settings. 0.15 millimeter speed is much different than 0.15 millimeter quality, but also all of these layer heights affect your printing time. So 0.3 millimeter draft is going to go a lot faster than 0.05. Another very important setting to consider is supports. So supports are needed when you have an unsupported overhang in your print that would otherwise fall if there's nothing under it. So if you look at this print here, you can see, if we zoom in a little bit, you can see that this overhang and a lot of these branches are unsupported, meaning that if left just like this in the G code after you slice it, this would fall while printing, obviously messing up your print. To compensate for this, you can go to supports and click. So there are multiple types of supports. We're going to go through just the two main ones, everywhere and build on support plate only. The first of which, support on build plate only. If you select, you'll see after we slice it, you can see it's generating support material here. You can see it'll add supports wherever it can, as long as the supports are on the base plate. So this has many advantages. It is very good for building things that obviously need support under them. One thing to keep in mind is that adding supports will add a lot of time to your print, so that's one thing to consider. Another thing to consider is spots that wouldn't be covered by these supports. So if you zoom in a little bit more here, you can see that we have some overhang right here. This is due to the fact that we have support on build plate only enabled. So it can't build a support on the print itself to support this. So if we go over here to support everywhere, also make note, with just supports on build plate, it's 7.5 hours. If we go to everywhere and then we slice it, you can see how much more support is added. Also compensating for the supports on the print itself, holding itself up. And that added almost roughly 2 hours to our print. So keep in mind, it also uses much more filament. So I would keep these in mind while designing your print and orientating it on your base plate. So for this next setting, this is a fairly simple one. Let's say you just wanted to scale your print up or down. So to do that, you can come to right here, Object Manipulation, and you want to go to your scale factors. So if let's say you wanted to keep your scale of your model the exact same, all you would do is go to one of these three boxes and change it by your desired amount. So let's say I wanted this Lego to be half as big as it is now. I would just type in 50, see it scales all the X, Y, and Z's the same way, and you can see it's half as big on our plater. Then obviously, alternatively, if you want to size it up, let's say I want it roughly 2 times as big, I can go to 200. You can see our Lego gets twice as big. The next thing we want to touch on is how to save on some aspects of 3D printing. So if you take this Lego here, for example, you can see that it looks solid, but if you look under it, you can see there's this empty space, of which if I wanted to print, I would need supports in. If we slice it, you can see it fills in supports. And if you look, you can actually see this is a really hard support area to get off after printing. You can see it's going to take some tools. It'll take a little bit to get it out, and if you want to print a lot of Legos, that stacks up over time. So a way to get around this is if we go back to our plater, you can select it, and then you want to rotate it. You want to rotate it 180 degrees, and it's going to put it back flat on the plate for you. And then by doing that, and then you can generate your supports. So let's slice it. You can see now it's this nice support layer that is right on top. It's not really stuck in between things. You can flip it right back over and take it right off the top. So this will save a lot of time. It'll save a lot of infill. It'll make it much easier for the printer, much easier on you to remove the supports. So that's something to keep in mind while you're orientating these on the base plate. You want to not only just import the file and then print it right away, you want to try and see if there's any ways to save time for yourself and for the print. So when considering what infill to use on your print, people often find themselves a little confused as to what infill means. So the literal definition of infill is the amount of the inside of your print that is filament itself. So for example, if my infill is 15%, which is generally the recommended amount to use, that means 15% of the inside of your print will be filament, and 85% will be mainly empty space. So what this means for your print depends on the filament you're using. When using generic PLA, for example, this won't affect the properties of your print very much. It will still feel about the same. It might feel a little more malleable depending on how low you put it, but it generally won't affect your print. Alternatively, if you select PETG, also known as Flex in our makerspace, infill will greatly affect how your print turns out. So when considering PETG, a lower infill may make your print much more squishy, for lack of a better term, as everyone calls it in the makerspace. So if you want a print that you can squeeze or that is really, really thick, we suggest changing infill accordingly. After deciding what kind of filament you want to use for your print, you should consider what fill pattern to choose. So if you click this little drop down here, you'll see there is a big selection of infill patterns to use. So each of these has their own pluses and minuses. So for example, 3D honeycomb and honeycomb, they're considered some of the strongest to use, as honeycombs are one of the strongest shapes. But if you don't like how honeycomb looks, maybe you want to use line or cubic or anything you want to use, we suggest looking up the pros and cons of each of these. I've seen a lot of people enjoy adaptive cubic, but again, it's completely up to you. Now we're going to show you the differences between PLA and flex filaments. This is PLA filament. This is the most common filament in the makerspace. It's one of two filaments. When you want to use PLA is when you want to print something that is very brittle and you want a very high tensile strength. It is very easy to break, like in half, but it will stay in place very well. So this is what you want to build for those types of situations. Now that we've covered settings and filaments, we're going to take you through the entire printing process, starting with loading filament. Before loading filament, you should preheat your printer. To do this, click the knob and navigate to Preheat, then select your filament type by clicking the knob on it. Once it's preheated, we suggest cutting the end of your desired filament diagonally to help the printer grab it. Once that's done, add the spool to the rack above your printer and firmly insert the end into the top of the nozzle as seen. Then, navigate to Load Filament and click the knob again. After clicking, the nozzle should pull the filament into itself. Your printer will then start extruding a small amount of filament and ask you if it is the correct color. If yes, you are ready to start your print. If no, select Load Filament again until it extrudes the correct color. Next, we'll show you how to add your print to the printer. Once satisfied with your print settings on Prusa Slicer, click Slice Now. After that, add your SD card and SD adapter to your device. as seen. Once inserted, click Export to SD and save your print to the SD card. Then safely remove the SD card by clicking Eject SD. From there, you'll want to insert the SD card facing away from you into the slit on the left of the printer screen. After doing this, navigate to the Print from SD option, click the knob, and then click the knob again once hovering over your file. If it asks you to update, simply click the knob again. If all goes well, your printer should look something like this as it's calibrating, and then should start printing.